You ever just look up at the night sky and think, where do all those stars actually come from? I mean, they don't just pop into existence, right? Well, today we're diving deep into their incredible birthplaces, giant molecular clouds. These things are the universe's stellar nurseries, and trust me, they've got some amazing secrets.
It's really the ultimate origin story, isn't it? You look at a galaxy, this massive city of light with trillions of stars, and you have to wonder, every single one of them had to start somewhere. So where is that somewhere? Well, the answer is actually hidden in the darkest, quietest corners between the stars.
And that somewhere, it has a name: giant molecular clouds. I want you to picture these as just colossal, churning factories that are constantly building stars out of cosmic gas and dust. These stellar nurseries, they're the main characters in our story today. Now, we call them clouds, but you gotta think way, way bigger. We're talking about these vast, freezing, and incredibly dark regions of space. They're packed with dense molecular gas, mostly hydrogen, and they're so thick they block all the light from behind them. This creates the perfect, quiet, hidden spot for stars to form, and that's exactly why we call them stellar nurseries. So, how in the world do we know all this stuff? Well, we look at our neighbors. Astronomers have pointed their telescopes at the Large and Small Magellanic Clouds, the Triangulum Galaxy, and a bunch of other dwarf galaxies that are relatively close by. Because they're right next door, cosmically speaking, they're like perfect little laboratories for us to watch star formation as it happens. Okay, but this brings up a huge challenge. If these stellar nurseries are, by their very nature, cold and dark, how on earth do you study what's going on inside them? It's kind of like trying to see inside a locked room that has no windows. And yeah, this is the core of the problem, right? In visible light, these clouds are just blank spots in the sky. They don't shine, they don't glow. To our eyes, they're just cosmic voids, and they are hiding their secrets completely. This is where the real genius of modern astronomy comes into play. How do you map something that's basically invisible? Well, you can't look at it, so you have to figure out a way to listen for it. And here is the absolutely brilliant solution. You see, the main ingredient, molecular hydrogen, is pretty much impossible to detect directly. But there's another molecule in there, carbon monoxide, or CO, that acts like a tracer. It gives off this faint but very specific signal in the radio spectrum. It's like a unique fingerprint. So by tuning their telescopes to that signal, astronomers can basically see the invisible, tracing the outlines and the internal structure of these dark clouds. So clever. Okay, so once we figured out how to peek inside these clouds and all these different galaxies, we found something completely unexpected. We found this remarkable consistency, this cosmic family resemblance that nobody was really expecting to see. And this was the huge discovery. It turns out it doesn't really matter if you're looking at a cloud in one galaxy or a cloud in another. They all seem to be built from the same universal blueprint. The basic rules for building a stellar nursery seem to be the same everywhere we look in our local neighborhood. And this similarity, it runs deep. Key properties, like how the mass is spread out within the clouds, are amazingly consistent. Even the complex scientific formula that we use to convert that CO signal into a total mass, it's the same from galaxy to galaxy. It all points to this one standard recipe for making stars. But these clouds, they aren't just sitting there. They have a life of their own. And as astronomers started to catalog them, they had a realization. They weren't seeing a bunch of different types of clouds. They were seeing one type of cloud at different stages of its life. This entire evolutionary cycle plays out over about 30 million years. So in stage 1, you just have a quiet young cloud minding its own business. Then in stage 2, gravity starts to take over, and these dense clumps start forming the very first stars, deep in the core. And finally, stage 3. This is the spectacular part. Brilliant, massive new stars burst into view, and their intense light and energy just blow away that gas cocoon, revealing the nursery to the rest of the universe. So we've got this really elegant life cycle. But that just brought up another question. Where does all the raw material to build these gigantic clouds and all of those stars actually come from? I mean, the clouds have to get bigger before they can start making stars. Right, because it turns out these clouds aren't just these isolated little systems. To get massive enough to actually start birthing stars, they have to actively feed on their surroundings. They've got to pull in more fuel. And that fuel comes from something astronomers call HI envelopes. HI, by the way, is just the sciencey name for single atoms of hydrogen, the most basic building block in the whole universe. And these huge invisible envelopes of gas wrap around the stellar nurseries, acting like a giant fuel tank. The whole process is actually surprisingly elegant. Gravity just pulls gas from that surrounding envelope right into the cloud. And as this atomic gas gets denser and cooler, the single hydrogen atoms pair up and they form molecular hydrogen, or H2. That molecular gas is the essential ingredient for making new stars. So the cloud is literally growing by consuming its own atmosphere. Okay, so let's zoom all the way out. We've seen how stars are born, we've seen how the nurseries evolve, and we've seen how they feed themselves. So what does this all mean for the big picture? It means these clouds, they're so much more than just clouds. They are the engines of galactic change. And this right here is the key takeaway. Because the properties of these clouds are so consistent nearby, it gives us this incredibly powerful template. Scientists think this model can be used to understand how stars form in galaxies that are much, much farther away, galaxies we can't see in this kind of detail. It gives us a key to unlocking the engine of galaxy evolution across the entire cosmos. So the big picture here is that star formation isn't chaotic. It's not random. It is a structured, pretty predictable process with a clear life cycle and a way to refuel itself. And it's this process, repeated millions of times over in thousands of clouds, that truly builds and shapes the magnificent galaxies that we see all around us. And you know, that leaves us with one last really fascinating thought. This whole grand process, it all depends on that fuel, those atomic hydrogen envelopes. So if these clouds are the engines of cosmic creation, what happens to a galaxy when those fuel tanks finally run dry? What does a galaxy look like when its star-making days are finally over?